Hello everyone, in this video we're going to talk about one-way analysis of variance, or I'm going to show you on how to solve a problem using one-way analysis of variance. In this problem we will assume that the data are normally distributed. We will not discuss here on how to check as to whether the data is normally distributed because this has been explained in the previous lesson. So we'll just go straight into the analysis of the data using one-way ANOVA. Okay, so we have here a problem. The effect of 3 different antibiotics on the growth of a bacterium was examined by adding them to petri dishes, which were then inoculated with the bacteria. The diameter of the colonies in millimeter was measured after 3 days. A control where no antibiotics were added was also included. The following results were obtained. So these are the diameter of the colonies under the control group. There are 14 colonies. Under antibiotic A, these are the diameter of the bacteria, and there are 14 cases here. 10 samples under antibiotic B, and we have 16 under antibiotic C. So the first step is to formulate the hypothesis. So for our null hypothesis, we can state that there is no significant difference in the mean diameter of the 4 groups of bacteria. And for our alternative hypothesis, we can say that there is a significant difference in the mean diameter of the 4 groups of bacteria. Now, step number 2 is to set the level of significance. In this case, we will use 5%. And number 3, we're going to identify the test to be used. We are going to use analysis of variance because we are comparing 4 groups of data. So we have the control, antibiotic A, antibiotic B, and C. Next is to compute the degrees of freedom. The first degrees of freedom that we're going to compute is the degrees of freedom between. The formula is number of columns minus 1. So we have column 1, 2, 3, and 4. So that's 4 minus 1. 1 is constant. So df between equals 3. Now for the df total, we are going to add n sub 1 plus n sub 2 plus n sub 3 plus n sub 4 minus 1. So our number of cases are already listed here at the bottom. So that is 14 plus 14 plus 10 plus 16 minus 1. And 54 minus 1 equals 53. Then let us compute for the degrees of freedom within, which is equals to df total minus df between. Df total is 53 minus 3, that is equals to 50. The next step is for us to determine the F critical at degrees of freedom 3, 50, and at 5%. The value of the critical F is 2.79, and we will locate this value from the table shown here. So this is the F distribution table, and this table is for 5% significance level. These values here are for the degrees of freedom between, and these are for the degrees of freedom within. So our degrees of freedom between, this one, this is our degrees of freedom between. This is 3, and our degrees of freedom within is 50. So the value, which is 2.79, is the one that intersects between the 2 degrees of freedom. So our F critical is therefore 2.79. Our next step is to carry out one-way analysis of variance using Microsoft Excel. So this is our data. What we can do is to click data, then select data analysis. Let's select single factor ANOVA, click OK. Let us select all the data here. Then label the first row. We're comparing by columns, and our level or alpha level is 0.05. For our output range, I would like to put the output here and then click OK. So this is now the results of the analysis of variance. As you can see, these are the counts for the 4 groups, the sum, the average, and the variance. What we can do is to copy this one. Let's copy this in our PowerPoint. So let's go back to our PowerPoint. So this is the ANOVA summary table. And as you can see, our DF between groups is 3. DF within groups is 50, and the DF total is 53. The sum of square between is 9.38, and the sum of square within is 12.12. The mean square was obtained by dividing 9.389 by 3, so that is equals to 3.129. This one, the mean square within groups, was obtained by dividing 12.126 by 50. And the F ratio was obtained by dividing MS between groups by MS within groups. So 3.129 divided by 0.2425 equals 12.09. The if critical was obtained from the table, which we have shown to you earlier. So now we are going to compare the F ratio and the F critical values. So the absolute value of F ratio, which is 12.905, is greater than the F critical, which is 2.79. Therefore, our decision is to reject XO and accept the alternative hypothesis. Therefore, we can say that there are significant differences among the mean diameters of bacteria. Considering that we rejected the null hypothesis, deciding which groups are different can be done by carrying out any of the following post-hoc tests. You can either use DMRT or Duncan's multiple range test, Toki post-hoc test, and Schiffe post-hoc test. We're not going to discuss this today, but we shall discuss one of these post-hoc tests in our next lesson. That's all for now. See you soon.